Thank you and welcome to our webinar, which is part of the ILC Dover 2021 Virtual Trade Show Experience. I'm Scott Patterson, and I will present a range of solutions for handling powders and upstream biopharmaceutical manufacturing. Let's get started. What problems are we solving with finding the right solution? This is information that we have gathered by understanding a day in the life of upstream bioprocessing. We ask processors what they want to fix, avoid, and accomplish. Here are some of the things that they told us. Reducing powder handling processes altogether was highly desired. This reduces labor and increases efficiency in the manufacturing process. Minimizing dust exposure is important, both for operator safety and for the environment. This reduces cleaning and reduces the risks associated with cleaning. Automation of the transfer bag handling system is very important. All facilities have limits on what the operators can lift, and by automating the transfer bag handling, we really protect the operators. Providing solutions to deliver powder into a hydration tank, effectively eliminating some of the problems such as clumping and floating of powders, really enhances the mixing process and makes the mixing process faster and more efficient. One of the big issues that we found was to reduce consumables for things like cleaning wipes and tools, other auxiliary pieces. This really eliminates waste and cleaning water and makes the process much more sustainable. Why are there different solutions for powder handling? These are some of the issues that we found throughout the biopharm market. Tank sizes and elevations for access to those tanks and the charge nozzles are different. We have some tanks that are smaller and closer to the ground level, while we have other tanks that are very large and located on mezzanine. So we have to come up with a range of solutions for those differences. The recipes for the volume and types of medias are different for each biologic, and so the transfer system that needs to be flexible to meet those differences. Powders definitely have different characteristics causing flow issues, mass flow issues, clumping of the powders, and went into hydration, foaming is an issue. So we looked at that and what solutions can be applied. Powders will have different mixing characteristics, and so we definitely want to improve how the mixing can be done and have a better mixing profile or speed of mixing. And the biomarket continues to migrate from durable technology to single-use systems. And so the different solutions have to be capable of a retrofit as we look at moving from a stainless steel type of system to a single-use type of system. So today we'll look at really 3 different technologies that can be implemented for better powder handling. The first is the 2-ported 3-dimensional powder bag, the EZ BioPac. This is understood to be the fastest and most accurate way to dispense powders into a transfer bag. Second, knowing that not always a transfer bag is used, that the technique of drum charging, where full drums are charged into a tank using a drum lifter drum inverter as shown in the picture. Here the cone liner was developed to protect the cone as part of the drum inverter. We eliminate the butterfly valve, we protect the cone, and we eliminate cleaning of those components. And then we have the JETMIXER, which is a very novel, unique powder into liquid delivery system that has mixing capabilities. This uses turbulent mixing instead of vortex mixing, and is a very efficient and effective way as a one-step powder into liquid and mixing system. So first we start with the 2-ported 3-dimensional EZ BioPac. Now the typical powder transfer bag is shown on the left, the 1-port 2-dimensional powder bag. This is a very typical product that's used when a powder bag is used in the powder charging process. So this requires a support frame, and as you can see, it has a stainless steel funnel to allow for a larger target because the 1-port is that tri-clamp connection, which is typically 4 inches or smaller. So very hard to quickly fill into a 4-inch diameter. But on the right, we're showing the EZ BioPac. This is the 2-ported 3-dimensional bag, and we're showing the filling process, which is a very open top port to allow for fast and accurate filling of the powders into the EZ BioPac. So looking at that a little bit closer and actually how the work is being done, dispensing is often done in a laminar flow hood or some controlled area. And so oftentimes there's limited space. So as we see the operator on the right in the picture, we look at the space that's needed. And here we have a 25-liter EZ BioPac and a very compact space, because when we're using a 3-dimensional bag, the volume per inch of height is much greater than a 2-dimensional bag. So you can see, very ergonomic to go from a total top to bottom of 40 inches for that filling process. So we have that large open target for filling quickly, which also allows us to adjust if it's overfilled. So the operator can remove powder very, very easily. No extra funnel or tools are required. Spillage is almost eliminated, so we don't have powder into the environment. We said that that was a desire of the bioprocessing areas, to eliminate particulate that gets into the environment. And here, we're not really seeing it in the picture, but the tri-clamp, which is going to give us a dust-free connection at the point when we're connecting to a tank, is a secure factory fold seal, assuring no bypass of powder. So after filling, the EZ BioPac can be picked up and transported without any risk of leakage from the tri-clamp. So in the 2-dimensional powder bag, and again, the single-ported 2-dimensional powder bag, as we see on the right, we have some filling challenges. The first is going back to that ergonomics. So here, again, with a 2-dimensional bag, not so much volume per inch of height, and so we have up to 57.5 inches on a 25-liter bag. So that's quite a height, almost 5 feet from where the operator may have to scoop from a drum or a pail to get product into the 2-dimensional bag. So that can create some ergonomic motion issues for the operator. Scooping from a pail or drum has that long reach. If the operator overfills, and we can see in the picture on the bottom that a smaller scoop or spoon has to be used to remove it, oftentimes the operators will fill very, very slowly so that they don't ever overfill, so that the filling process is very inefficient. And then when we look at it, as you can see on the picture of the 2-dimensional bag, we have a red clamp that's put in place after filling. So the operator has to apply that clamp and apply it correctly after powder has passed through that neck to close the bag, because it will be inverted for charging. And the operator is charged with doing that to make sure that there's no leakage. So that's an extra risk that the operator takes on, and a challenge with these 2-dimensional bags when we have to fill into this one port and discharge from the same port. So this 2-dimensional single port bag has several issues when handling in the filling process and then in the discharging process. So eliminating any parts and any cleaning and any risks is all part of the powder transfer process. So here with the EZ BioPac, we recognize that the typical connection, almost 100% of the time, is a tri-clamp connection at the hydration tank or whatever tank it might be going into. So the tri-clamp connections is a technology that was developed in the dairy industry for liquid applications. And so it comes with a loose sanitary gasket to make sure that we have a liquid tight seal. Well, here on the powder side of the biopharmaceutical market, we really don't have that challenge of a liquid. We have a solid, the powder, that's flowing. And so here, the EZ BioPac was developed to integrate that gasket as part of the tri-clamp flange. This really eliminates that risk of a loose gasket. Let's say that gasket falls on the floor. The operator probably needs to have a spare ready, or has to go to stores to get another gasket. There's also a risk of that gasket getting into the process. That's a worst case scenario, but by eliminating that gasket altogether is a very key point and a benefit of the EZ BioPac. So taking a deep dive into that gasket, it really is important, because we do need that dust tight transfer of powder into the tank. So we get this with the integral co-molded gasket with the tri-clamp. And again, the tri-clamps with the EZ BioPac are available with a full range of tri-clamp sizes, 1.5 inch, 2 inch, 3 inch, 4 inch, 6 inch, 8 inch, and some of the European standards, the 100 DN and the 150 DN. This is critical because the EZ BioPac can be adapted to almost any tank with one of these sizes and not requiring any type of transfer connection to meet the size that's on the tank. So the EZ BioPac comes ready to connect directly to the hydration tank. Now, powder hang-up and retention in the transfer is also a critical issue. When we look at the filling process, the filling of a powder transfer bag has a very tight tolerance that's applied to it. So why apply a tight tolerance to the filling if we're going to lose a significant amount during the transfer? And in a two-dimensional bag, the loss is really retention in the powder bag. And this is because of how the powder bag is welded together. As you can see, the welds really are similar to what a pillowcase would be. So we have these pinch seam welds that come down the side, and these are areas where powder can hang up. So again, why go through the diligence of a very accurate way if we might lose 100, 200, 300 grams? The two-dimensional bags do have a solution for that, and that's the rinse nozzle that you can see here. So with the rinse nozzle, after the discharge is done, and knowing there can be some retention, let's say WFI is connected and the internal of the bag is washed out, but that's very time-consuming and another waste of the process to make it inefficient. So we look at the two-dimensional bag as having inherent challenges in meeting the requirements for charging powders. So let's add up the advantages of using the EZ BioPac. We reduce the extra components and cleaning materials, so we make the system a bit more sustainable. Saves time in powder dispensing, we see that. Less retention when discharging. We don't need a rinse nozzle to get the discharge complete from the EZ BioPac. And we reduce the risk of contamination, or let's say dust exposure. All of this leads to about a 60% time savings when using the EZ BioPac. We did a case study where we looked at 25-liter powder bags in a batch of 50 units. And so we compared the EZ BioPac with the single-ported two-dimensional bag. As we go through this, we found there is a significant reduction of labor, which is a reduction in cost, which improves the efficiency for additional production, increasing profits. Really, we look at it saying how many more batches per month or per year, how many campaigns can be run by looking at these type of savings. And really, when we look at these savings, the bottom line here in our chart is the hours saved. So we have 10 hours when doing a batch of 50 units of the EZ BioPac, and over 17 hours, almost double, when we're looking at the single port two-dimensional bag. So extremely efficient when using the EZ BioPac, and that time savings can be used to increase production, which is really a big impact on efficiency. Now, when handling powder transfer bags, again, all plants are different. We do have facilities with smaller tanks that can be accessed from the ground level, but more often than not, we see that larger tanks are located on mezzanines, and so operators, have to access those through typically the stairs, as we show in the picture here. Many times in working with customers, we see the fire brigade, if you will, of operators handing powder bags to each other to get to the top. So we want to eliminate that type of problem. That's one of the issues we looked at from a standpoint of operator safety and when handling the powder process. How do we reduce operator risks? One of the ways is automation of the powder handling bag system. And here we're showing an automated lift system, which is extremely efficient when handling multiple powder transfer bags. This system is offered by Nito Systems and it has been developed to handle the EZ BioPac in a range of sizes. So powder transfer bags are brought to the lift mechanism through carts or trolleys, and we'll take a look at the trolleys next. Loading occurs at the floor level, so we can manually load bags that are less than 10 kilo, and those are put onto hooks onto the lifting mechanism. And multiple bags are put on. So this lift can take multiple bags lift them up so an operator can connect one, do the discharge, and while in the same area without going down the stairs, stay in that location, connect a second, perhaps connect third and fourth. And so it becomes a very automated and efficient way to do it. And even with larger bags, as you can see, we have a cart here with the quote lifting halo. So the lifting halo is designed to lift 25 kilo, 50 kilo, even 100 kilo EZ BioPacs to position those over the nozzle. You can see the graphic on the far right that this automated lift also pivots into position to be able to swing over a nozzle that may be hard to access. So this is a very efficient way to lift multiple bags in position and saving the operator the time of up and down the stairs. Another effective way to move the powder bags in the facility is a trolley system. So here we're showing a non-metallic trolley that's cleanable and reusable. So this trolley can be used to actually fill as a frame to fill the powder bag, and or multiple powder bags can be filled and then placed in the trolley and moved through the facility. So as you can see, it's a closed system. So this can move through non-GMP areas and protect the powder bags from having any type of contamination as that movement occurs through the facility. And this unique design creates a trolley train. So one operator can move multiple trolleys together. These trolleys hook together so that one operator can easily roll multiple units, and this becomes very, very effective versus the one-off kind of movement of a cart or pallet through a facility. So the trolley and the trolley train has become a very efficient and effective way to move powders into position to start the charging into a tank. And we spoke about the cone liner in use of the drum inverter system. So this technique was very common in the early days of charging powder in bulk into tanks and using the drum inverter. It's still used, and many customers have applied the cone liner. So the cone liner follows the geometry of the stainless steel cone as part of the inverter, and it also eliminates the butterfly valve. So when the drum is inverted, there must be something to hold back the powder. And here we use the same technique as the EZ BioPac at the discharge. We have a factory fold that is only released after the inversion is done and we're ready to discharge into the tank. This is also very effective for kitting of powders. So you can see in the picture on the right that multiple drums can be discharged into one large powder transfer bag, a large EZ BioPac, if you will, up to 700 liters. And so kitting of powders can be done by dumping drums into a large EZ BioPac while protecting the cone and reducing the amount of cleaning that needs to be done. So let's talk about the fundamental challenges of getting the powder into a mixed tank. So up to now, we've really focused on the powder bag technology, which can be done effectively and efficiently, but there are other techniques. And here we'll be moving towards the idea of automation of getting the powder into a mixed tank. It's a fundamental issue, and oftentimes the tank is elevated on a mezzanine, which makes the challenge even greater. And this is the typical kind of layout where we have elevated tanks, and operators will have to use mezzanines or stairs to access the top of where the powders will be charged to. We really want to eliminate that fire brigade of operators handing bags or carrying bags upstairs. Again, there are weight restrictions in every facility of what an operator can lift. So we don't want to overburden the operator by having to lift heavier and heavier powder bags. So we're looking for a way to eliminate that altogether with a different technique than a powder bag. So the ergonomics are clear. Again, we want to get to the top of the mezzanine. We need to get the powder into the hydration tank or the mixed tank. Once we get up there, that can be a challenge as well, as it can be very crowded. There can be piping and plumbing at the top. But the number one problem that we've seen as getting to the top of a hydration tank is the clearance to the ceiling. in a lot of cases, that clearance is very small and doesn't allow for a powder bag to be lifted and positioned above the tank. And in a lot of cases, the restrictions could mean that very small powder bags would be used, which means a lot of connect, disconnect, a lot of charging that has to go on. So we're looking for a technique that can deal with this crowded real estate or a low clearance between the top of the tank and the ceiling. So there's the fundamental challenge. How do we get the powder up there? What other techniques can we do other than the powder bags? So we want to make this as easy as possible and think about all of the issues when it comes to cleaning, exposure, dust contamination, and what have you. So the first thing that we looked at was dense phase pneumatic transfer. Can we use a pneumatic transfer system to transfer powder from the floor level to the tank? This is a very common process used in pharmaceutical manufacturing as well as food manufacturing when solids are used. So here, the pneumatic transfer seems like it could be very effective, but in the diagram, all of this is piping or hosing that would require cleaning. And that could be problematic when using multiple different medias or buffers to be able to, the need to clean in between. So we found that customers didn't feel that dense phase pneumatic transfer systems was appropriate for the biopharmaceutical world. Now, again, in the discussions with customers, we found a very common technique of using a rotor stator device. And the rotor stator can be seen as a pump. It can be seen as powder delivery. It can be seen as a mixing system. But the rotor stator is again, a very unique device where it creates a high shear and uses a tremendous amount of energy when in the process. So we found the rotor stator, although it is used in handling medias and buffers to get into a tank, the cleaning that is required with a rotor stator type of pump and the additional energy that's put into the system really isn't desired. So still looking for a better technique to do this transfer. This is where the JETMIXER, which we introduced early in the presentation, can be very effective. So the JETMIXER is a unique novel system that uses a low shear type of system for not only powder feeding, effective powder feeding, but also aids in the mixing of the process. So the JETMIXER uses a very simple pump and creates a velocity of the water that goes through an eductor. In that eductor, a venturi is created. And with the venturi, the powder is loaded into a hopper, and particle by particle, the powder is pulled into the flow. This is very, very effective for poor flowing powders that have issues with flow and getting it into hydration. And we found that even in using hot water, which we've seen in a lot of processes where, let's say, glucose is added as a media, that heated water can cause many issues in getting the powder into the process. And the JETMIXER has been found very effective to be able to meet the requirements of those hard to feed materials. Also, the delivery is done without any foaming occurring, and that's a big deal. Materials like when soy is added into the process can cause a good deal of foaming into the tank. And so here we found that the JETMIXER eliminates that type of a problem. And the JETMIXER can be put in a remote location. So this is an interesting concept where the JETMIXER does not have to be local at the hydration tank or the mix tank. This could be located in an area or a different room away from the tank, and even perhaps in a non-GMP area where powder could be loaded. And simply, it's a matter of pump technology and the physics of the pump and being able to transfer the powder liquid addition over the distance and the height that's needed. So here we show in a remote location, just by simply adding a second pump in parallel will give us the ability to remote the process. And again, that keeps the environment where the mix system, the hydration tank, much cleaner, and we have no powder exposure, no dust contamination at all. Here are examples of the JETMIXER, with the top left being a very mobile system. In the middle, the picture in the middle is again a mobile system with a JETMIXER that's located below a braking device. So we know that in a lot of cases, media will agglomerate and become a solid and need to be broken up before putting into the hydration tank or mix tank. So all of these techniques have been adopted in different ways, but you can see that the JETMIXER can be a very compact, portable skid to meet the requirements of powder into liquid as well as liquid mixing. So moving on, we also look at the single-use systems, and going back to the powder bag technology, that this is different than handling liquids. And what we found that in a lot of cases, powder bags that are used have been adopted from what were liquid bags, and that includes that pinch seam weld that we talked about that tends to hold powder in the weld corners and so forth. So those techniques were developed for liquid bags where retention is not a problem. Here we're showing a very large volume EZ BioPac, the 140 liter EZ BioPac, which has the capability of 100 kilograms. So this is where, again, when we're handling these powders, failure is not an option. This bag cannot fail due to the load, have a weld failure, or the lifting loop. So it has to be a very secure system. So here's where a made-for-purpose film is used for the manufacturing of the EZ BioPac. The tensile strength becomes very critical, and this film in the EZ BioPac ArmorFlex applies a high tensile strength and really has an elongation before failure of over 500%, and that's an example of how strong this film is. The design of the three-dimensional also allows for the distribution of the load much better than a two-dimensional bag. A two-dimensional bag basically puts all the stress on the discharge. Here you can see with this shape that the bag itself can support a lot of the load, and it's not just solely focused on the discharge. And there's a different weld system used on the EZ BioPac than the two-dimensional bags. Again, we've referred to that pinch seam weld on the two-dimensional bag, but here on the EZ BioPac three-dimensional, there's a lap seam weld system that's used. And a lap seam is taking a connection point where two pieces of the construction are going to be welded together and overlapping those by a full 1 inch. And with that 1 inch overlap and the weld done across that, it makes the weld the most secure area. So in a lot of cases, powder transfer bags, the weld is the suspect area of failure. But with the EZ BioPac, the weld is actually the strongest part of the assembly. So with that, we can make larger size EZ BioPacs to handle larger volumes. And why is that key? Well, for the processor, let's take the example if 100 kilos of powder was going to be charged in 4 lots using 25 kilo, and we'll say those are 25 liter bags. So 4 lifts, connections, disconnections have to be done. So instead of using 4, by having the capability of a very strong assembly of a large volume, we can go to a single 100 liter bag. So that makes the whole process much more effective and much more efficient. So by having the materials and the construction method to be able to use a larger volume is very important. And so when we look at that material, it's always key in the biopharm industry to understand, is this compatible with the process? So the ArmorFlex material is a very interesting material because it is a single structure of a monolayer film. It's a combination of linear low density polyethylene and low density polyethylene, but those are blended together and extruded as a monolayer. There's also an anti-static additive that's blended in with it, and that anti-static additive is key also for the retention to allow for the powder to be released fully into the tank when charging. Now, again, key in the biopharma industry is extractable and leachable. So this material has gone through the typical industry standard testing, such as the BPOG testing and other testings to qualify for those stringent extractable and leachable requirements. So the material is characterized, in this case, the ArmorFlex in grade 114 is characterized with the regulatory qualifications as well as the critical physical properties that the material has. So this film has a full range of regulatory compliance, and then again, the individual extractable and leachable tests that are done by companies themselves or by following standards in the industry like the BPOG extractable and leachable protocol. And these powder transfer bags have to be manufactured in an environment not only using a material that is characterized correctly, but the manufacturing has to be done in a clean room. And so the ArmorFlex is manufactured in ISO 7 certified clean rooms, and those clean rooms also are certified to ISO 11137, which is the VD Max protocol. So here with bioburden control, we can do the manufacturing of the EZ BioPac and then go through a gamma irradiation process and have certification for sterility. So this is key, not only with the ISO 7 certified clean room, but also the ability to gamma irradiate and have a sterile product when needed. So a quick case study here of a company that actually implemented the two-ported three-dimensional EZ BioPac. A little bit blurry, some of the cell phone pictures here weren't the best photography, but it tells the story anyway. So in step one, the customer was using stainless steel bins to move their powders through the facility. So from the dispensing room to the hydration tank. So in step two, we want to modify those stainless steel bins to have an open top with a liner and tri-clamp. So that was the first step to try to move away from having stainless steel bins that had to have a significant amount of cleaning. As we went forward, the process went into step three. So we eliminated the stainless steel bins altogether and use these lightweight frames to hold the actual EZ BioPac. So here's where the EZ BioPac began its use. So in those frames, the EZ BioPac could be filled and transported, but you see in step four, the EZ BioPac is lifted independent from the frame and then charged into the process. So this eliminated a tremendous amount of cost in cleaning for this company, cleaning of those stainless steel bins, but they were also into an expansion, and so they were going to have to purchase a significant amount of bins, which would require a significant amount of floor space as well as additional cleaning equipment for those bins, washing machines and so forth. And so there was a dramatic CapEx savings by going to the EZ BioPac from using the stainless steel bins as the original technique. And this is where we talked about one of the challenges and why we have different solutions for powder handling is, in this case, it was a retrofit of an existing process. So coming up with a way to do it basically the same way so that the SOPs aren't impacted that much and change control isn't that complicated, but still getting the job done by using the EZ BioPac. So in summary, what we've presented today is biopharm powder handling is not the same in all facility, and we really need to look at options that are available to meet each demand. The two-ported three-dimensional bags are purpose designed and built for powder handling. So the EZ BioPac was developed specifically for the idea of handling powders, and it wasn't a derivative of a liquid bag process. Lifting systems are very effective and can reduce operator manual operations, and we want to protect the operators from the risks of having to move powder bags upstairs and so forth. Powder into liquid can really be solved quickly by using the JETMIXER, a very effective way to get powder into liquid and to have that mixing process started. Materials of construction, very critical. Qualification and performance always needs to be considered when using a single-use product. And looking at the business case for using the right solution, whether it's a facility upgrade or better performance. So in that short case study, we saw a dramatic savings that customer realized in CapEx as well as operational savings by no longer having to clean those stainless steel bins. So with that, we thank you for your attention today, and we hope that this information was valuable for you. Thank you.